A few weeks ago, I showed you how to use NgRx entity adapters. Today, I'm going to build on this concept and show you how to use Firestore as a persistent backend data source. You might be aware that Angular Fire version 5 has a new state changes method, which we're going to take advantage of in this episode. It makes it possible to keep track of when documents are added, modified, or removed. If you want an example of how this might be used, look no further than the Firebase console itself. If we add a new value to the database, you'll see it flashes green for a split second, and the document itself is modified so it flashes orange. If we remove the property, then it flashes red. The Firestore web console happens to be built with NgRx, which I learned by watching Angular Air episode 135, so make sure to check that out as well. If you're new here, click the subscribe button and follow along with the source code at angularfirebase.com. To get started, I'm going to first show you how we have this app set up based on the previous video. Starting with the app module, the main change we made is we installed Angular Fire 2 along with Firestore. I'm also including the NgRx effects module, and in the root, just passing it an empty array. If you're lost at this point, make sure to go back and watch the NgRx entity video. From there, I'm going to go into our pizza feature module, and I have a new file called pizza effects that we're going to create later. We also import the effects module here, but call forFeature and pass it the pizza effects file. The actual app we're building is just a collection of pizzas, and the user has the ability to asynchronously update them from a status of cooking to delivered. The thing that's interesting is that this app is going to listen for the state changes coming from Angular Fire 2, and then use entity adapters to update the local data store. Currently, I've queried all the pizzas that have a status of cooking. So if the status changes from anything other than cooking, it should be removed from our local data store. If we update the status from cooking to delivered, you'll see that it gets removed from the local data store, and that action is triggered here in Redux DevTools. The key takeaway here is that you'll always know how your data is changing relative to the way you queried it from Firestore. Let's go ahead and set up the NgRx actions that make this possible. The first action is query. Eventually, it's going to make a query to Firestore and listen to any changes that happen to that data. And from there, we're going to set up added, modified, and removed. It's important that you keep these names consistent because they're returned to us from Angular Fire 2. I also want to show you how to update data on a Firestore document. So we'll set up actions for update and success. Each of these actions will have a class that implements the action interface and has a custom payload that we define in the constructor. The query action doesn't need a payload, but the added action will return an individual pizza object, so we can type that to our pizza interface. Then modified and removed will also follow the same exact pattern. They simply create a payload of a pizza object. The update action is a little more interesting. It's going to take an entity ID as well as a partial piece of data that we want to update on the interface. Normally, TypeScript wouldn't let us do this, but we can use the partial type with our pizza interface to update individual properties on the object. The success action is only used to show us when a successful update operation has been completed, so there's no need to add a payload to it. Then the final step is to export all of these actions as a single type. Now we're going to jump into the reducer, and I'll go through the whole thing from top to bottom. So first, we're going to import the actions we just created, as well as a few things here from NgRx. Then we'll define our pizza interface, which just has an ID, a size, and a status, which can either be cooking or delivered. Then we can use this interface to initialize our adapter. This will give us access to a bunch of helper methods to update the state consistently. From there, we use entity state to extend the main state interface. This ensures that our data conforms to a specific format for entity. And if you have some initial data you want to set as the initial state, you would do that here, but for now I'm just going to leave it blank. Now we're ready to build the reducer function. It takes the old state as well as the action that's being dispatched, which will be one of our pizza actions. And then we'll set up the switch statement here, and the first one we'll look for is added. So whenever we get a new item that's added, we're going to add one pizza to the state. That will add one new pizza to the state and keep track of its ID and everything automatically. For modified, we'll call update1, then pass it the entity ID as well as the changes that we want to make. Then the same basic idea for removed, but this time we'll call remove1, and it takes the ID as the argument. With just these three actions in the reducer, we can throw around all kinds of different asynchronous events while providing a ton of feedback about our local data store. The last step is to create the selectors that allow us to slice various pieces of the state. That's done by calling create feature selector, and then NgRx gives us a bunch of built-in helper methods, or you can create your own to slice different pieces of the state. In this demo, we're only going to be using select all. Now we're ready to build the NgRx effect. The effect will allow us to isolate asynchronous events, so we don't have to actually trigger those events from inside a component. In other words, components should only dispatch events and select parts of the store. They shouldn't cause any asynchronous side effects on their own. We're also going to be using the new lettable operators from RxJS 5.5, so the import syntax is slightly different as you see here. The first thing I'm going to do is inject the actions as well as the Angular Firestore library in the constructor. The most important effect here is query, and that's going to make the query to Firestore for a collection and handle the added, modified, removed events that come from that collection. So first we call actions of type with the query action. That returns an observable, so we can pipe multiple RxJS operators here, which will make our code more readable than it has been in previous tutorials that I've shown you about NgRx effects. The next step is to make a query to Firestore, so we do that by calling Angular Firestore collection, and then we're going to only query the pizzas that have a status of cooking. Then to get an NgRx-friendly observable from Firestore, we call state changes. That returns an array of actions, so we'll map that down to each individual action by calling merge map. Then we can dispatch the correct action based on what's returned from Firestore. So we'll call pizza with the action type, which will be added, modified, or removed, and then the payload will be the actual data that we update on the local store. We want both the data and the document ID, so we can map those together here in the object. That's all there is to it. Your local data store will now stay in sync with the data in Firebase, and you'll have a lot of flexibility for managing those changes. But we're not quite done yet. I still want to set up one more effect so the user can manually update data in Firestore. This time we're going to listen to the update action, and when that occurs, we'll map it down to the data payload. That has the document ID as well as the data that we want to update. From that point, we call switch map, and then with the data that we want to update, we'll make a reference to the pizza in Firestore. Then the update action is going to return a promise, so we're going to create an observable from that promise. To take care of that, you can do observable from promise and then make the update inside of it. And lastly, we'll map that down to the success action once that promise resolves successfully. It'd also be a good idea to catch errors here and dispatch an error action, but I'm skipping that part for now. We're almost done at this point. We just need a component for the end user to interact with. We'll go ahead and import NgRx store as well as the actions and reducer that we just created. Then our actual observable will be an array of pizzas. The store is injected in the constructor and it's typed to our pizza interface. We'll make the initial query during ng on init, but first we'll select the slice of the store we want for our pizzas variable. After that, all we have to do is dispatch the query action. And our front end is going to have some buttons where the user can update the state of an individual pizza. The update pizza method is an event handler that will bind to a button click, and we can just dispatch the update action with the corresponding payload. The HTML code is incredibly simple. We just loop over the array of pizzas, and then for each one, we'll add that update status button. Clicking this button will trigger an asynchronous write operation, which will update the pizza from a status of cooking to delivered. Now let's go into the app and take a closer look at what's actually happening here. The initial page load pulls the data from Firestore and then adds it to the state in the entity format. If you look at the actions, we first have a query pizzas action, and then we have 4 added events after that. And of course, that gives us 4 pizzas on the screen here as well. Now let's see what happens when we click the update status button. We get 3 actions here. First the update, and then it's removed from the local store, then update success after the actual update promise resolves. So even though the pizza wasn't removed from Firestore, you still get the removed action because it was removed from the local store. You could use that state change to toggle a CSS class or show a toast message or any other UI element you can imagine. Now let's take a look at one more thing. What happens if we update a property on a pizza from Firestore or any other client subscribing to this data? You'll see down here in DevTools we get a modified action, which tells us that the data on the pizza was updated, but it still remains in our base query. The end result is that you now have a system that will detect changes in Firestore and tell you exactly how they affect your local NgRx store. That's it for NgRx with Angular Fire 2. If this video helped you, please like and subscribe. And if you want to learn more every week, consider becoming a pro subscriber at angularfirebase.com. You'll get access to exclusive content, a free copy of my book, as well as a bunch of other resources designed to help you get your app off the ground. Thanks for watching, and I'll see you soon.